Introduction. Death by GPS and the crystal that could see through fog. Imagine this. You're driving down a remote, winding road at night. The sky is black. Rain is pounding your windshield. You have no landmarks, no sense of direction, and yet you're calm. Because on the dashboard, a little blue dot is glowing like a promise. The GPS says, "Next right." So you turn. You trust it completely. That trust has a name now. Death by GPS. In 2015, a driver in Indiana followed his GPS onto the Klein Avenue Bridge. Except the bridge had been closed and demolished. He drove straight into emptiness. In Death Valley, a mother and her child followed a shortcut the GPS recommended and ended up stranded in a brutal, empty landscape for days. In Australia, tourists drove into ocean mud because the map insisted the water was a road. These aren't just freak stories, they're a symptom. Somewhere along the way, we traded a basic human survival skill, spatial awareness, for a glowing dot. We stopped reading the world and we started obeying a screen. Now hold that thought and step into a completely different world. It's the year 950 AD. You're standing on the wooden deck of a Viking longship deep in the North Atlantic. The waves are heavy. The air is freezing. There is no land, only grey water and grey sky. There's no magnetic compass in your toolkit, and for days, a thick, suffocating fog has swallowed everything. No sun, no stars, no horizon. By modern logic, you are finished, lost in the largest graveyard on Earth. And yet, the Viking commander doesn't panic. He walks to the bow, reaches into a leather pouch, and pulls out a small, semi-transparent crystal. Just a chunk of rock, barely larger than a fist. He holds it up to the blinding fog, turns it slowly, and then stops. He points into the whiteness. "West," he says. "We sail west." And days later, you hit Greenland. So how is that possible? How did a people we casually call barbarians cross the most hostile ocean on the planet with a kind of confidence that modern humans struggle to match without satellites, servers, and signals? Today on Historia Prime, we're uncovering the Viking Sunstone. What it was, how it worked, and why the logic behind it matters right now, in an age where our navigation systems can be jammed, spoofed, or simply disappear. Because if you can't trust the blue dot, you'd better learn how to find your way in the dark. Part 1. The Masters of the Open Ocean. To understand how extraordinary the Vikings truly were, we have to see the ocean the way they did. Between the 8th and 12th centuries, the Norse were not just raiders hugging coastlines, they were ocean navigators of the highest order. From the fjords of Scandinavia, they crossed the brutal North Atlantic, settled Iceland, pushed onward to Greenland, and even reached North America, Vinland, 500 years before Columbus. Their highway was the 61st parallel north, a vast corridor of open water stretching from Norway to Greenland. And their strategy was elegant in its simplicity: latitude sailing. First, sail north or south until you reach the correct latitude. Then turn due west. Hold that invisible line across the ocean until land appears. Simple in theory, deadly in practice. Because holding a straight line in the North Atlantic means fighting currents, crosswinds, storms, and weeks without seeing land. Drift just a few degrees off course over a 3-week voyage, and you will miss Greenland entirely. You won't hit another continent. You'll drift into an endless, freezing void. When the skies were clear, Viking navigators used a remarkable tool: the sun compass. Archaeologists uncovered a fragment of one in 1948 beneath the ruins of an 11th century site at Unatok in Greenland. It was a wooden disc with a central pin, the gnomon. As the sun moved, the shadow aligned with carved curves on the board, revealing true north with surprising precision. But here's the problem. Viking sailing season was summer, and at those extreme latitudes, Summer means the midnight sun. The sun barely sets. The stars, including Polaris, vanish in the glow for months at a time. They had to rely on the sun. And what happens when the sun disappears behind days of thick fog and heavy cloud cover? The North Atlantic is infamous for it. Endless grey skies, soupy mist, storm fronts rolling in without warning. Without a magnetic compass and without the sun, a ship becomes a leaf on water. Currents push, winds drift, bearings dissolve. The Norse had a word for this nightmare: hafvilla, to be utterly lost at sea. And yet, they were not lost. For 3 centuries they maintained trade routes, settlements, and cultural links across thousands of miles of hostile ocean. That does not happen by luck. It does not happen by instinct alone. It happens because somewhere in their navigational system there was a backup, a layer beneath the sun compass, a method that worked even when the sky turned blank. The Vikings had a secret weapon, and it did not depend on clear skies. The bow reaches into a leather pouch and pulls out a small, semi-transparent crystal, just a chunk of rock barely larger than a fist. He holds it up to the blinding fog, turns it slowly, and then stops. He points into the whiteness. "West," he says, "we sail west." And days later, you hit Greenland. So how is that possible? How did a people we casually call barbarians cross the most hostile ocean on the planet with a kind of confidence that modern humans struggle to match without satellites, servers, and signals? Today on Historia Prime, we're uncovering the Viking Sunstone, what it was, how it worked, and why the logic behind it matters right now, in an age where our navigation systems can be jammed, spoofed, or simply disappear. Because if you can't trust the blue dot, you'd better learn how to find your way in the dark. Part 2. The Magic Crystal of the Sagas. For centuries, the only trace of the Vikings' mysterious backup system was not found in a laboratory or an archaeological dig, but in legend. Buried inside a 13th century manuscript known as the Saga of King Olaf, there is a strange and almost casual detail. The story describes a day of heavy snow and complete cloud cover. The sky is sealed in grey, no blue, no sun. The king turns to a navigator named Sigurður and asks him to point to where the sun is hiding. Sigurður gestures toward a patch of blank sky, but the king wants proof. So, according to the saga, the king made them fetch the solar stone and held it up and saw where light radiated from the stone, and thus directly verified Sigurður's prediction. The solar stone, the Solarstein. Another medieval text, the Rafn saga, mentions it as well, claiming that even when no blue sky could be seen, the stone could capture the sun's beam. For a very long time, historians dismissed this as myth. The Sunstone was filed away next to Thor's hammer and sea serpents. Colourful storytelling, nothing more. The assumption was simple. The Vikings relied on instinct, experience, and luck. And to be fair, their natural navigation skills were extraordinary. Modern researchers call it lattice navigation. Instead of trusting a single tool, they layered information. They released ravens and watched which direction the birds flew, knowing they would seek land. They tracked whales that followed stable ocean currents. They listened for the rhythm of waves reflecting off distant shores. They even claimed they could smell the faint, earthy scent of land long before it appeared on the horizon. They read the entire environment as if it were a living map. But even the most skilled observer faces a hard limit. In the middle of the North Atlantic, wrapped in thick white fog, with no coastline, no birds, no visible horizon, and no sun. Instinct is not enough. You need a bearing. You need a fixed direction. You need to know where west is. And this is where the story shifts from mythology to science. In 1967, a Danish archaeologist named Thorkild Ramskog proposed a radical idea. What if the Sunstone wasn't magical at all? What if it was a real mineral, used not as superstition, but as a precision optical instrument? In other words, what if the Vikings weren't guessing at the sun behind the clouds? What if they were measuring it? Part 3. The physics of the invisible sun. To understand the Sunstone, we have to understand light. When sunlight leaves the sun, it vibrates in every possible direction. But once it enters Earth's atmosphere, it collides with air molecules and scatters. This process, called Rayleigh scattering, is why the sky appears blue. Yet it does something even more important. It polarizes the light. In simple terms, the scattered light organizes itself into patterns. It forms invisible rings around the hidden position of the sun. So even when thick clouds block the sun, or when it sits just below the horizon at twilight, the sky still carries a hidden signature of its location. The human eye can't see that pattern clearly, but certain crystals can. In 1967, Thorkild Ramsco proposed that the Viking Sunstone was likely Iceland spar, a clear form of calcite found in abundance in Iceland. This mineral has a remarkable property called birefringence, or double refraction. If you place Iceland spar over a single dot, you see two. The crystal splits one beam of light into two separate rays. Now imagine a Viking navigator standing in heavy fog. He looks straight up through a piece of Iceland spar and slowly rotates it. Because the sky's light is polarized, the two images inside the crystal shift in brightness as he turns it. One grows dimmer, the other grows brighter. There is one precise angle, known today as the isotropy point, where both images appear equally bright. When that balance is reached, the navigator has identified the exact orientation of the polarized light, and from that, he can determine where the hidden sun lies. With surprising accuracy, within about 1 degree, a trained observer could locate the sun even when it was invisible. And once you know where the sun is, and you know roughly what time it is, direction becomes simple. North, south, east, west. The power wasn't mystical. The stone itself wasn't magic. The real breakthrough was this. Centuries before modern physics formally described polarization, Viking navigators were using it. They had effectively built a natural optical sensor, one that worked without batteries, without magnets, and without satellites. In a sky that looked blank to everyone else, they were reading an invisible map. Part 4. Proving the legend. For decades, the Sunstone theory was attacked from every angle. Critics argued that the human eye could never detect such subtle changes in light. They insisted that clouds would destroy any usable polarization pattern. In short, they demanded proof. So scientists went looking for it. In the early 2000s, research teams led by biophysicists such as Gabor Horvat recreated the exact sky conditions the Vikings would have faced: heavy cloud cover, dense fog, and the extended twilight of Arctic summers. Using full-sky imaging polarimetry, they measured the polarization patterns hidden in overcast skies. What they found was decisive. Even under thick cloud cover, the polarization structure of sunlight remains detectable. In large-scale computer simulations of voyages from Norway to Greenland, researchers tested what would happen if a navigator used a calcite sunstone periodically, just once every few hours. The result was striking. Success rates exceeding 90%. The stone was not folklore. It was a viable navigational instrument. But perhaps the strongest evidence came not from simulation, but from the sea itself. In 2002, divers exploring the wreck of an English warship that sank near Alderney in 1592 recovered a cloudy crystal block lying beside navigational tools. Analysis confirmed it was Iceland spar, cut into a precise rhombohedral shape. By the late 16th century, magnetic compasses were already in use. Yet those early compasses were unreliable near large iron cannons, which could distort magnetic readings dramatically. A crystal capable of locating the sun through clouds would have been an invaluable backup. In other words, centuries after the Viking Age, European sailors were still quietly relying on the same optical principle. What began as saga had become science, and what looked like myth had proven to be engineering, so robust that it endured for 500 years beyond its origin. Part 5. The Twilight Board, Navigating the Dark. But the Viking breakthrough didn't end with finding the hidden sun. Knowing where the sun is only matters if you can turn that knowledge into direction, into a steady course across open water. Recent research suggests the Norse combined the Sunstone with their wooden sun compass in what scholars now call the Twilight Board. Picture the moment just after sunset. The sun has slipped below the horizon. The sky is dim, washed in Arctic twilight. The navigator lifts the sunstone and determines the exact azimuth of the sun, even though it is no longer visible. Then he places a carved stick, sometimes called a shadow stick, onto the compass dial and aligns it with that direction. By doing so, he creates an imaginary shadow, as if the sun were still above the horizon. He matches this artificial shadow to the engraved curves on the board. In that instant, he locks onto true north. Sun compass in clear weather. Sunstone under clouds. Shadow stick at twilight. Together they formed a continuous system, one that worked day and night across shifting skies and changing light. It wasn't luck, it was layered logic. The Vikings did not depend on a single signal. They built redundancy into their navigation. And that simple principle, never rely on just one source of truth, may be their greatest lesson of all. Part 6. The Fragility of Modernity and the Lesson of the Vikings. So why does any of this matter to us now, sitting in climate-controlled homes with satellites orbiting overhead? Let's return to that little blue dot on your phone. What feels like a simple convenience is actually the invisible backbone of modern civilization. Global navigation satellite systems, GPS among them, don't just guide you to a coffee shop. They synchronize financial markets down to the nanosecond. They stabilize power grids. They guide cargo ships, aircraft, ambulances, and military systems. The modern world runs on timing and positioning signals beamed from space, and those signals are astonishingly fragile. By the time a GPS signal reaches your phone, it is weaker than a household light bulb shining from 12,000 miles away. That means it can be jammed, it can be spoofed, it can be distorted by interference or overwhelmed by electronic warfare. In recent years, spoofing incidents have surged, especially in conflict zones, forcing ships and aircraft to question their own instruments. Commercial pilots have reported false terrain warnings. Navigation systems have placed vessels miles from their true position. And there is an even larger threat: the sun itself. During severe solar storms, coronal mass ejections, the ionosphere becomes turbulent, scrambling satellite signals and potentially damaging power infrastructure on Earth. A powerful event could temporarily blind satellite navigation across large regions. We have optimized our society for clear skies and perfect signals. But when those signals fail, the illusion of certainty collapses quickly. This is where the Vikings offer a profound lesson. The Norse did not rely on a single point of failure. Their method was layered. If the sun was visible, they used the compass. If clouds covered it, they used the sunstone. If conditions shifted again, they read birds, currents, waves, and wind. They practiced what modern thinkers call redundancy. They built resilience into their navigation. By contrast, many of us have outsourced our spatial awareness entirely. We follow instructions turn by turn without noticing landmarks, horizon lines, or cardinal directions. When the battery dies, orientation disappears with it. But here is the striking twist. Modern engineers are quietly rediscovering what the Vikings understood intuitively. Aerospace and defense researchers are investing in alternative positioning systems that do not rely on satellites, systems that read environmental signals instead. Among those signals is polarized light in the sky, the same invisible map the Sunstone revealed. In other words, the principle behind the Viking crystal is not obsolete. It is returning, because a system rooted in physics, light scattering through Earth's atmosphere, cannot be hacked in the same way a digital signal can. It cannot be turned off by a jammer in orbit. It is always present, written into the sky itself. And that is the deeper message. The Vikings survived not because they conquered nature, but because they understood it. They built layers of awareness. They cultivated skills alongside tools. Perhaps the practical takeaway for us is simple. Use technology, but do not let it replace perception. Notice where the sun rises and sets. Pay attention to the shape of the land around you. Learn the cardinal directions of your own neighborhood. Rebuild a mental map. Because the most resilient navigation system has never been purely mechanical or digital. It has always been a partnership between tools and the human mind. Conclusion: the invisible map above us. The story of the Viking Sunstone is not just an intriguing detail from the past. It is a mindset. The Vikings did not survive brutal seas by overpowering nature. They survived by understanding it. When the sky turned grey and hostile, they didn't see an obstacle. They saw information. They learned to read what others ignored. They combined observation, physics, and discipline into a system that worked even when the obvious signals disappeared. So what does that mean for us? It means technology should serve us, not replace us. The blue dot is powerful, but it is only one layer. Real resilience comes from layers: awareness, skill, backup, and understanding. Notice where the sun rises. Learn the basic directions of your surroundings. Pay attention to landmarks. Rebuild your internal compass. Because the sky still carries its invisible map, the world still offers its signals, and the ability to read them has never truly vanished. Thank you for exploring with Historia Prime. If this journey changed how you see navigation, and perhaps even modern life, consider subscribing and share this with someone who trusts the blue dot a little too much. Until next time, keep your eyes on the horizon and never stop exploring.